Yesterday was more of an intro, like here's full stack, here's a curriculum, and today we'll be starting to dive into kind of the more technical aspects and starting to review concepts that at first may seem simple. And I think one of the most common things that I hear from students in this program is that things are usually very easy when someone explains it to you and kind of walks you through it. And then when you try doing it yourself, it gets a lot harder very, very quickly. So I'll be a little bit fast through the slides because I think conceptually most folks have seen a lot of this before. But I do want you to kind of spend more time on the workshop because it may not be as easy as the slides make the material seem to be. Okay, so today we're talking about loops and debugging. Loops are probably one of the most common things, concepts, whatever you want to call it. They'll definitely be one of the most common things that you will use in programming in any language. So we're going to dive a little bit into what loops are and kind of how they work underneath the hood. And then we'll do a little bit of a session on debugging too. Although the debugging session is more of a lifelong skill that you pick up over time. We'll get you started for sure, but it's not something we kind of teach and kind of in one go the way that we do for loops or maybe some of our other kind of more compact or more kind of well packaged topics. Okay, so loops in JavaScript are just basically loops are an extension of doing something many times. And essentially, it is actually kind of fundamentally why we have computers, right? Computers are really good at doing the same task many times faster, more accurately, with a lot more ability than any person could. And so there's quite a few types of loops in JavaScript. The first one we'll talk about is the while loop. And so the while loop, if you're familiar with it, if you remember, it takes in three elements. There's the while keyword, there's what we call a conditional expression, and then there's a block of code. Okay. So if I look at line 6 through 8, right, like those three lines more or less embodies my entire while loop. So there's a while keyword, right, and literally when we say keyword in JavaScript, it just means that word, right? So if I type while, in most code editors that support JavaScript, when you type in the word while, it will actually show up as a different color in your text editor. And the reason for that is because while, like a lot of other things in JavaScript, are what we call reserved words, right? Reserved words are built into the language and they mean something very specific. And so what that means is, for example, we cannot have a variable called while, right? Because while already means, in JavaScript, it already means what I use when I want to start a while loop. So when I say the while keyword, it just means it shows up in different color. It's a word that's predefined and it has a very special meaning, which we're going to talk about here. Okay, so the first part of this is just the while keyword. After the while keyword, notice we have an open and close parentheses, and within it we have something called a conditional, and we'll come back and talk about the conditional expression in a little bit. But for now, just kind of, the conditional basically means that it's something that we evaluate or something that we solve for. Okay, and then lastly, after we do the conditional, we then have our open curly braces followed by the block of code that we want to be inside of the while loop, aka what we actually want to be executed, followed by the closed curly brace. And notice again on line 7 there, because line 6 ends in an open curly brace, that means everything after line 6 is indented by 1 unit until we get to the close of the curly brace, which in this example is on line 8. Sorry, I have a bit of a side cough still. Okay, so what a while loop basically says is, if my conditional, right, if that thing that I'm solving for is true, then I'm going to do whatever is in my block of code. After I'm done doing whatever is in my block of code, I'm going to check my conditional again and see if it's true or not. If it's true, then I do my block of code again. After that, I check again. If it's true, I do my block code again. And basically, this sequence will go on, indefinitely until one of two things happens. Either the conditional becomes not true or it becomes false, and we'll see a few examples of that in a little bit. Or from inside the loop, we send it an explicit message to stop, which we will also see in a little bit as well, right? But fundamentally, all a while loop is saying is, hey, while this condition is fulfilled or true, keep doing this block of code over and over and over again. So if I was to take a look at an example here, on line 1, I have a variable called count. I set it equal to 3 initially. And then on line 3, I have my while statement. In it, I have my conditional, which is count is greater than or equal to 1. And then I have my open curly brace on line 3, I have my code block on lines 4 and 5. Line 4, all it does is it console logs out count is, and then the variable, or the value of count. And then on line 5, what we do is we do count minus minus, which is a shortcut or a shorthand for saying let's subtract 1 from count. Okay, and then on line 6 we close the curly brace. Once again, notice on lines 4 through 5 they are indented, right? Because that tells us that we are in the code block of the while loop. And so if I was to run this code, on line 1 I create a variable. On line 3 I do the conditional. I check is count greater than or equal to 1, right? That's my condition. Is it being satisfied? Does that return true? And so when I initially run it the first time, the variable count is equal to 3, so 3 is greater than or equal to 1. So then I move on to line 4, which means I print out count is 3, and then on line 5 I subtract 1 from count. So now count is 2. Okay. After I do that loop, I then go back to my conditional. I check again, is count greater than or equal to 1? And the answer here is yeah, count is 2, and 2 is greater than or equal to 1. So then on line 4 I console log out count is 2, and I subtract 1 from count again. So now count is 1. Okay. I go back to my conditional on line 3 and I check, is count greater than or equal to 1? So is 1 greater than or equal to 1? And the answer is yes, it is. It's equal to 1. So then on line 4, I console log out count is 1, and I subtract 1 from count again. So now count is 0. I go back to my conditional and I say, is my conditional still being met? Is count greater than or equal to 1? And at this point, count is 0. So count is not greater than or equal to 1. And so because of that, I can say, great, I've now finished my while loop because my conditional has returned false. Okay, while loops essentially keep running until the first time and only time it gets the conditional to be false. Once the conditional is false, then it knows to stop and it moves on to the next line in the code, which in this case will be lines 7, 8, etc. Oh, sorry. Okay, so any questions on that walkthrough I just did of how a while loop works? Everyone's good with that? Cool. All right, so if we notice the way, oh, sorry, go ahead. Someone have a question?
I have a question.
Yeah.
This is Anna K. I understand the count is portion of the block code, but why is there comma count after?
Oh, that's just a shorthand. With those console logs, whatever it is that you put in there, it will just append it together when it prints it out. So you could also do something, for example, you could also do something like this, like plus, and what it'll do is it will just append these two parts together into one string.
Is by itself.
I'm sorry?
It couldn't just be count is by itself.
If I use the plus sign?
No, like just count is, close parentheses.
Then that just prints out count is.
Oh, okay, gotcha. Thank you.
Yep.
I understand.
Cool. Any other questions? Cool. Awesome. So alternatively, one of the things that we did in our previous example is when we did our first condition, right? We said it was true, so then we started running the code block. Well, here I have another while loop, except in my condition. Notice how in my condition on line 1 there, right? In between the parentheses, all I have is a false. Okay. On line 2, in my code block, I have a console log that reads out this line of code will never run. And indeed, if I was to actually run this code, run the code on this page, on line 1, I would hit my while loop, and then the condition will say, great, is your condition true, right? Is what's in between the parentheses true? And the answer is no, it's not, it's false. And so if it's false, then we just stop, right? We say, great, our while loop is over, let's move on to the next line of code, which is line 4. And the reason why I show you this is just to kind of give you the sense that it's not guaranteed that a while loop is always going to run at minimum X number of times, right? Here's a clear example where we have a while loop and it will never run, or rather, the code block on the while loop will never run. The only way to know whether or not a while loop will run is to make sure that the conditional becomes true, right? So when we run this piece of code, nothing happens on this page because as soon as we hit the false under the conditions, we know we're done with the while loop and we move on. Similarly, if we take the opposite approach and we now put in a true in between the conditional, well, then what's going to happen is we're going to have something we call an infinite loop, which means that this code will run forever. Okay, and the reason for that is because if I look at the code, right, and the first time I run this, I check my conditional. Is it true? Is what's in between the parentheses on line 1 true? Yes, it is. So I console log out this sentence. I then check my next line and say, great, is it conditional true? And the answer is yes. So then I print out the next line. And this will go on infinitely, right? Because true on line 1 will never be false, right? It's never going to change. And so this will actually just always run over and over and over again, nonstop, until most likely most computers right now, nowadays are advanced enough that if they see you do something like this, they'll usually run it a few times, like, hey, I think this is an error, or I think this is a mistake. But just like how with the conditional initially being false, we never start. Here's an example where we never stop. And so this kind of brings up this really important point that we saw in the first example, but I just want to kind of highlight again here, which is that the conditional, it's really important when you have a while loop to make sure that the conditional is moving towards false. Okay, and so here on line 4, I have this for loop that just says, well, count is greater than or equal to 1. On line 5, I console log out count is, right? So this looks very, very similar to the example we saw on page 1. The only difference is here now is after line 5, we don't have anything that decreases count by 1. And so because of that, if we run this, we see the same problem, the same infinite loop problem, right? Count is initially equal to 3, and that's greater than or equal to 1. And if we never change count, then we know that on line 4, that conditional will always be true because count will always be equal to 3, and 3 is always greater than or equal to 1. And so we see our same infinite loop problem as well. Okay. This is pretty much kind of as deep as I can go into for while loops. But at the very fundamental level, we just want to make sure that you understand kind of the process and the order in which things are running, right? So it's always conditional first. If it's true, then we run the code block. If it's false, then we end the code. Okay. If we do run the code block, then we check the conditional again, and then if that's true, we run the code block. And if that's true, we run the code block. And if at any point the conditional becomes false, then we end the while loop. So are there any questions on while loops before we move on to for loops? Everyone feels good about it?
Yes, sir.
Is this the only while loop, or we have any other while loops in JavaScript? It's the only while loop and it's a while loop.
This is the only kind of while loop. There's something called a do while loop that runs something at least minimum once. It's not much more complicated, but it's not something that we talk about really in this curriculum. Okay, so then moving on to for loops. A for loop is actually one of the things that you, as you get more familiar with these loops, you actually realize that and basically for most programming ideas, you can do the same thing in a variety of ways. And one of the things that you'll discover very quickly is that actually for a lot of for loops, you can write them as while loops or rewrite while loops as for loops. So they're actually interchangeable in the sense that they could both be used to accomplish the same thing, right? And that redundancy is definitely by design. And so in the same way that with a while loop we have 3 pieces, with a for loop we also have 3 things too, although in my opinion number 2 is kind of cheating because it's actually 3 additional things. Okay, so the parts of a for loop are 1, the for keyword, and just like the while keyword, it's a reserved word in JavaScript, which means it will show up in different color in most text editors, and it means that you cannot have a variable called for, right? Because it already means something in JavaScript. Now, instead of a conditional expression in between the parentheses, a for loop has 3 things, of which the middle is a conditional expression, or in this case, we just call it the condition. But it also has 2 other things: the initialization, which comes first, and then the third thing, which is called the final expression. One really quick syntax thing here that a lot of people really kind of just gloss over or don't internalize is there are 3 things in that expression, and each of those things are separated by a semicolon. Not a comma, not a period, not a dash, not a colon. They're separated by a semicolon. And so that's just one small syntax thing that I think a lot of people get tripped up over. Okay, we'll talk about what each one of these things do. But number 1, we have our for keyword. Number 2, we have our 3 optional expressions inside of the parentheses after the for loop. And then lastly, just like in the while loop, we have our open curly brace, our block of code, which is properly indented, followed by our closed curly brace. Okay, and what this will do is if I was to describe a for loop, it actually sounds identical to the while loop, right? which is to say that the block of loop will run again over and over until the conditional expression becomes false. Okay, so let's take a look at what this looks like in practice. The first thing that happens is we have something called the initialization. And the initialization is run first every time the loop is run, and it is only run once over the entire life of the for loop. So it doesn't matter if your loop loops 1,000 times or if it does the same thing 1,000 times. Your block of code might run 1,000 times, but your initialization step, so everything before the first semicolon in the conditional or in the parentheses on line 9 there, that only runs once, right? So in this example here, let I equals 1 only runs once. So that means we only create one I variable, and generally speaking, that the initialization, I guess, clause or part of the for loop is used to create a counter variable or something for us to use to keep track of how many times we've run it or how many times we intend to run it. Okay. Then the next step of the loop is to say, okay, let's move on to the next part of our expressions, and here we reach our conditional. Okay, the conditional here operates in the same way as our conditional from our while loop, which is to say that we evaluate that expression and we get back either a true or a false. If it's a true, then we keep going. If it's a false, then it means our for loop is over, and at that point we stop the for loop. Okay, if it is true, then, and this is where it's a bit different, rather than moving on to the next, in the example here, rather than moving on to the third optional expression, we actually just move on to the code block and we execute the code block. After we exit the code block, then we come back to the third part of to the third optional expression, which in this case is I++, so we add 1 to I. And then here's where the loop starts. Then we say, great, let's check our conditional again. If it's true, then we'll run the code block, and then we'll go back to our final expression, and then we'll go to the conditional, and if that's true, we'll go to our code block, and then go to our final expression, and so on and so forth. Okay, and so I know that was kind of a lot of words, right? But here I'm just going to stop the slide really quick and kind of highlight this. This part here, this initialization, this will only run once. Okay, after that, we run this part of the for loop. If this is true, then we run, well, in this case, we run this part of the for loop. Then we run this. Okay, and that's one iteration of the for loop. On the next iteration, we check this again to see if this is true or not. If it's true, then we run this, and then we run this. Okay. And so basically the parts of a for loop that loops over are this part, and then this part, in that order over and over and over again until this becomes false, or as we'll see later, until certain other conditions are met. Okay, and so if I was to actually run this block of code now in a step-by-step way, step one is to say, great, let's do our initialization. Let's say I equals 1, so we create an I counter. Then we go into the middle conditional and we say, is 1 less than or equal to 3? And the answer is yes, it's less than 3. So then we go to our code block and we print out I is 1. Then we go to our final expression where we add 1 to I, so now I is 2. Then we go to our for loop and our conditional, again we check, is 2 less than or equal to 3? And the answer is yes, it is. So then we go to the code block on line 10 and we do a console log of I is 2. Afterwards we go to I++, which adds 1 to 2, which is now 3. So then on line 9 we check, is I less than or equal to 3? And the answer is yes, it's equal to 3. So then we console log out I is 3. Then we add 1 more to I, so now I is 4. And then we do our conditional, we check, is 4 less than or equal to 3? And the answer is no, it's not. So therefore that conditional is false, and therefore this for loop has ended. Okay. So that was a lot of me talking, but does that make sense to everyone? How a for loop is working? Is there anyone for whom that did not make sense, or there's any questions around what I just said?
I have a question.
Yep, go ahead.
Why, when is I++ optional? Like, what would that look like?
So theoretically speaking, you don't have to put anything in a third argument, because in the middle part, you're conditional. Here we're using I to check to see whether we get true or false, right? You don't have to use I. You can use any other variable that you want, and so theoretically you don't even need to have a counter. And so those are more kind of rare conditions, and if you're doing that, then it kind of begs the purpose of why you're using a for loop, or if there's a better way to do it. So you're right in that you don't necessarily have to have that third thing there, but by convention, most of the time you do.
Okay, I see.
Yeah. Cool. Any other questions? Okay. So then, if that makes sense, then the rest of these should be really easy, right? Loops, therefore, usually you see loops as going up by 1, but as we just saw, right, between the initialization and then the conditional check, and then the third part, which is where we edit the counter, nothing about this says that we have to go up by 1, right? All we're doing is creating a variable in the first step. In the middle step, we're checking it, and in the third step, we're editing it, right? So in this case, what we do is we start at I equals 5. We say, well, I is less than, or rather, well, I is greater than or equal to 1. And then after every iteration, we decrease I by 1, right? And so when we do this, we start at I equals 5, and we go all the way until I is 1, or rather, technically speaking, until we get to I is 0, right? So there's no limit on we have to increment by 1 or go down by 1. We can go in any direction that we want. And there's also no rules in that case about whether or not we have to go up by 1 even, right? We could go by any number. And so here in this case, we start with I equals 100. We say, well, I is less than or equal to 300. And then after every iteration, what we do is we do I plus 100. Okay. And so once again, the first portion, we're defining a counter. In the middle part, we're checking a counter. And on the third part, we're just editing that counter. And so as long as those 3 criteria are met, the for loop doesn't care if you're making numbers bigger or smaller. It doesn't matter if you're adding them by 1 or 100. It's all fair game as long as those 3 steps are being fulfilled. One of the things that you will see in today's class, and if you notice, I use my name as a variable just to show you that the counter can be any variable name that you want. Here, one of the things that we'll see is a for loop is actually really useful for going through, for being able to go through something that's iterable, right, or something that has a sequence of things. In this case, on line 2, we create a variable called letters, and it's a string with 7 letters in it. And if we use our for loop here, I can use the variable David as my counter, right? I can create any variable I want because my counter is just a variable, so I can name it anything I want. Here I said let David equal 0, while David is less than letters.length. And then after every code block run, I then add 1 to the David counter. And all I do is I say let the current letter equal letters index of David, and then print out that letter. On line 5 there, on the right-hand side, letters, and then the square bracket notation, what that does is that says, hey, give me the element, or give me the letter in this case, at that position, right? Because David is a number. And so with every string, the index starts at 0, and then we go all the way up to the very end. And so the highest index for any string is the length of that string minus 1, right? Normally we count starting at 1, and we go to, let's say in this case, 7. Here, because we start at 0, therefore we only go up to 6. So therefore, on line 5, we have a let current letter equals letters index David, which will give you the letter at index David, right? And notice how after every time I run this code block, David changes, right? Because in the third part of my for loop, I am adding 1 to David. So David starts at 0, then we say is 0 less than letters.length, which is 7? And the answer is yes, it is less than. So then we do current letter equals letters index 0, which is the letter A. We print out current letter, which is A, and then we go to our third part of our arguments and we do David plus plus, right? So the 0 becomes 1. And then we do our loop again. We say, is 1 less than letters out length? So 7. And the answer is yes, it is. So then we do our code block again. And then letters index of 1 is saying what letter is at position 1. Well, position 1 is a second letter, so it's B. And therefore we print out B. And we do this over and over and over again until our condition is not met anymore, right? And so when is condition not met? Well, by the time David gets to 8, we say is 8 less than, or rather when David gets to 7, right? Is 7 less than letters.length? And the answer is no, because letters.length is 7, and 7 is now less than 7. It's equal to 7, and therefore at that point we end our for loop. And so by doing this, we're able to print out every single letter in the string, one letter at a time. Okay. Yep. So does anyone have any questions up to here? Cool. So the last two things we'll talk about with regarding to loops is there's two more things we need to talk about. One is a continue keyword, and then one is the break keyword. So what the continue keyword does is a continue keyword will actually allow you to skip the rest of this cycle, but continue on to the next cycle. Okay, and so what does that mean? Here I have a for loop on line 2 that starts at I equals 1, while I is less than or equal to 5, and then we increment I by 1 after every co-block run. On line 3 there, right, notice how we say if I is equal to 3, we use a continue keyword, and continue is a reserved word, so that means we can't have a variable called continue. In any case, we have our if loop, and then on line 7, we have our console log that says I is, whatever the number I is, right? And so the really important thing here for us to just realize and remember is that what the continue keyword does is it will say, great, skip the rest of this iteration, but go on to the next line. And so therefore, if I was to run this loop, the first thing that would happen is I equals 1, right? Is 1 less than or equal to 5? Yes, it is. So then we go to line 3 in our code block. Is I equal to 1? No, it's not. So then we skip our if condition, and we go to line 7, and we print out I is 1. After we do that, we go back to line 2 into the third part, and we add 1 to I. So now I is 2, right? Is 2 less than 5? Yes, it is. We go into our if block on line 3 there. Is 2 equal to 3? No, it's not. So we skip all the way to line 7, and we print out I is 2. Now, here we do so here after I is 2, we then add 1 to I, so now I is 3. We do our conditional check, is 3 less than or equal to 5? The answer is yes, it is. So then we go to line 3. And on line 3, we ask, is I equal to 3 or not? And the answer is yes, it is equal to 3. Then we go into line 4, and we hit continue. What continue does at that point is it says, great, skip lines 5, 6, and 7, and then go on to the third step of keep moving towards your third optional argument. So we skip lines 5, 6, and 7, and we move on to I++, right? So at that point, I is 3. When we do 3++, we get back 4. We then go to our conditional check. We say, is 4 less than or equal to 5? The answer is yes, it's less than 5. So then we go to line 3 again. Is 4 equal to 3? No, it's not. So then we skip to line 7, and we print out I is 4. And then subsequently, we also print out I is 5. And so what I'll continue is saying is, skip the rest of the lines in your code block for this iteration or for this run, and just go straight to the next change or to the next final expression. In this case, it basically says skip the rest of this loop and go on to the next iteration where we do I++. And so whereas it works in for loops, it will also work in while loops as well, right? So all continue is saying is skip the rest of this iteration and move on to the next check or the next step in the loop process. Does that make sense to everyone?
Yes.
Yes. Wait, can you go back one slide?
Sure.
So if you had initialized with I is equal to 3, the only thing that would have happened, and you maybe like changed the condition to I is less than 5 instead of less than or equal to, the only thing that would have happened is I is 4 would have printed and that would have been it.
Yep, exactly. Was there another question? Yeah.
With line 6, we
Sure.
probably like yesterday's lecture, but why do we have like empty lines like that?
That just is really visual. It kind of separates one block of code from the other. It's the same way, like, when you write like a paper, sometimes people indent the paragraphs. Sometimes people just put a line in between paragraphs and makes it a bit easier to read. It's entirely a stylistic choice. There's no functional reason for it. Although if you do have a lot of, generally speaking, kind of like when you write English, you want to separate different ideas by putting a line between each paragraph. When you write programs, typically speaking, you also want to put a blank line between different pieces of code that are doing different things. So you can kind of group together like, oh, in these 4 lines, I'm trying to do this. In these 3 lines, I'm trying to do this. It just makes it a bit easier to read.
Okay, cool. Thank you.
Yep. Any other questions? All right then, so that's our continue keyword, and it works in for loops. It also works in while loops, and how it works in while loops is the same exact way. We skip the rest of this loop, and then we go immediately to our next check, right? Our next conditional check. So here in this case, if count remainder of 2 is equal to 0, basically saying if a number is even, we subtract 1 from count, and then we continue. So we skip lines 8, 9, 10, 11, and we go straight back to line 4 to check to see if count is greater than or equal to 1. Okay, so that's a continue keyword. The other keyword we'll take a look at is called break. And break, I think, is more drastic and in some ways a bit more easy to understand. Whenever you see a break keyword, it just means end this loop. That's it. End the rest of this iteration and also end all future iterations as well. And so if we go back to the example we saw earlier, right, on line 4 there, notice how if we initially look at that, we're like, wow, that's an infinite loop, right? Because while true, well, true is always going to be true. That's never going to stop. And so this loop will run infinite times. But if we go inside the body of our code, line 5, line 6, line 7 says if my grade.length, so we can say that my grade is maybe a string perhaps, if this string.length is equal to 3, then in line 8 we go in and we break. And so what that means is skip line 9 and also skip the rest of the future iterations of this loop, basically end it here now. And so basically between lines 4 through 10, for this while loop, the only way for us to exit this loop is for us to get to a point in which my grade's length is equal to 3. Right? Break just ends the loops then and there. And so here, if I console log it out, I see that indeed by the time that I exit the loop, my grade is a plus plus, right? So the length is equal to 3. And if I was to see this in the context of a for loop, same idea here. All we're saying is on line 5 through 7, so we start at I equals 10. We say, well, I is greater or equal to 1, and then we subtract 1 from I each time we run the code. And each time we do it, the code block says I is the number, whatever it may be. But on line 5, we say, if I is equal to 7, break, which basically means if I is equal to 7, end your loop. And so when we print things out, we print out I is 10, 9, 8. We print out I is 7, then we hit line 5, which is true, so we go to line 6 and we break, and that just means we end the rest of the for loop too. Okay, so break is also a way for us to end loops in addition to having the conditional being false. Any questions here? Cool. All right then. So that's all we have on the loops portion. Debugging part, I'll talk more about at high level because a lot of these are things I will be kind of practicing, and you'll definitely pick up as we do more and more workshops. First things first, though, don't get frustrated by debugging. Just know that most developers spend way more time fixing code than they do writing it. In fact, writing it becomes simple because you're just kind of getting things on paper, and you need to make sure that it works and works very accurately. But whereas debugging is actually where you might take up a large portion of your product development time, right? It's just once you do it, going back through and fixing the things that don't work or didn't work as you expected it to. So yesterday we talked a little bit about using CodePen, right? And we showed you kind of the UI for using it. But yesterday, it was kind of easy because when we started, every single test was passing, right, out of box. And once again, that was by design. We wanted to show you that when you use bad syntax or bad grammar or bad spacing, JavaScript, the language, doesn't penalize you for it, but other human readers will. But starting from here on out, now when you start any function, or now when you start any workshop problem and you initially run the code, all the tests will be failing because basically we're saying, hey, write me a function or write me a piece of code that will pass all of these tests. Okay, and so when we do use CodePen as the workshop when you use CodePen for the workshops, when you run it, it will tell you not only how many tests failed, but it will tell you which tests were failing, right? And so here, this is just a matter of us being kind of more diligent in reading the code. I'm going to exit presentation. I get my cursor back here. This line here in the red, this will tell you the name of the test that's failing. And we try to name the tests usually something that is somewhat descriptive, so you kind of see where we're going. And then inside of here are the different errors that we're seeing, right? And so the way to read this is we call this a stack trace. And so what a stack trace is saying is, hey, I try to run this, which made me run this, which made me run this, and this broke, right? So basically the highest line that you see is usually the last thing that broke. And the way to read this actually is in your onlyodds.js file on line 11, character 7, okay? Now, if we think about kind of a lot of times what happens is we make a mistake in one area, but we don't see the consequences of that mistake until much later in the code, right? So yesterday, remember how if you were to fix kind of one piece of spacing very randomly in the middle of a code, you might not realize that, hey, something higher up is actually broken in terms of spacing, and now everything after it is also broken. Same idea here. The stack trace is the way for you to kind of see how a computer is approaching this problem, but it doesn't always necessarily mean that the problem is right here, right? The problem could have shown up here, but it could have been caused somewhere else in the code. So while this is a good starting point, that's all it is. Don't treat it as the end all be all. Secondly is this line up here will usually tell you what the error that we're seeing is. In this case, we're seeing something called a reference error. And a reference error occurs when basically you're trying to use a variable that you either, one, have not created yet, or two, does not have access to at the point in which you're trying to use it. Or three, and this is probably most common when you're first starting off, is you just misspelled the name of the variable, pretty much. Okay, so these are all things that the CodePen app has built in, and they're things that we think will be really helpful to you as you get started in terms of helping you understand what we're trying to do, but also helping you see where the errors are as well. Yep, and this is just a more of an explanation on this stack trace. So once again, it goes from oldest, newest, newer, newest. So this is the latest line of code that failed, and then this will also tell you the line number and also the character number. But usually the line number is more than sufficient for you to figure out what the error at least is showing up right now. Failing test, right? So a test could fail for two reasons. One is you wrote bad JavaScript and it doesn't run, right? Something isn't running, and so therefore you're failing the test. The other way that something could also fail is if saying, hey, the code ran fine, but just didn't give me the right answer, right? Like I could, write like a essay, right, and not use English, and my professor would say, well, that's a failing test because I can't read it, it doesn't compute, right? And that's one type of failure. The other one could be I write a beautiful essay that's very well written, but I give the wrong answer, right? And so here, when you're looking at the test failures, and I can't stress this enough, always know what's failing, right? Or always understand what's failing before you move to fix it. A lot of times when a test fails, someone just says, oh, great, let me fix it. And by let me fix it, what they mean is let me go back and rewrite the entire function. But in reality, that's not very helpful because when you don't know what's broken, like how do you fix it, right? If you take your car to the mechanic will always ask you like, hey, so what's going on? What's the problem, right? They don't just say, oh, great, here, give me your car and I'm going to rebuild it from scratch, or rather I'm going to fix everything, because they don't know what's broken. And so for you, whenever you see a failure, always make sure you know what's broken before you go in and fix it, right? In this case, we'll see that that it's broken because we expected one answer, but we got another. And that just means the code ran fine, but that there was a logical misstep or mistake in our calculation somewhere. And then obviously expected blank to equal blank. That's just a way for the test to tell you, hey, I expect to get 55. Sorry, I expect to get back 25, but instead I got back 55. And then last but not least, and this is something also I think people just kind of appreciate more over time. JavaScript, every function in JavaScript will always return something, and if you don't tell a function what to return, then by default it will return undefined. Okay, and so a lot of times people will write a function and then they'll get this error saying expected undefined to equal number. Well, and they ask, well, I didn't return, or I didn't give back undefined anywhere. And the answer is, okay, that's fine, but did you return anything else? Because if you don't return anything else, then by default JavaScript is going to think that or JavaScript is going to return undefined on your behalf. Okay. Also, console logs and returns are very, very different. Console logs are just things that print out to the screen that makes it easier for the human reader to see. Okay, they don't actually mean anything to computer programming, to a computer program. And so when we say, hey, can you give me back a result? What that usually means is use the return key, right? Return a value to us. That's how JavaScript passes information from one function to another function. Console logs is purely for human use, and it's it doesn't move move code around. It's just purely for display purposes. Yep, so this one's very similar to what we saw before. The debugger I'm actually not going to talk about, just because the debugger, and we also have a few slides on Chrome DevTools as well. If you have any questions on and because you've been using this before, let me know. But what I've found is that at this stage, these things actually do more harm than good. Ultimately, like what we don't want you to do is we want you to have these tools at your disposal, but at this step, we really want you to be able to kind of reason through and logic through the code to really understand what's going on. And a lot of times when you use kind of more advanced debugging tools, it makes the issue more confusing than it really is. Most of the time, if we make you talk through, hey, what's your code doing? Like usually through that process, you'll be able to figure out what happened. Okay, so like I said, debugging is more of an art than a science. Here we're just giving you some very basic things for you to start. And today is the first workshop, so we'll definitely make sure that you're getting started on the right foot here. But you know, it's impossible to have a comprehensive set of debugging features, and so we just want you to kind of know how to get started. So on that note, you know, going back, today we talked a lot about loops, so we talked about while loops and for loops, as well as a break and continue keyword, and then we did a little bit on just kind of debugging basics, especially within the confines of the CodePen app. So are there any questions before we get started on the workshop for today?
Hi, I have a question.
Go ahead.
So on the slide in debugging,
Okay.
there's a thing, yeah, expected and to equal.
Yep.
So which is the one we were like expecting? Is it the 5.5 or 2.5?
I believe in this case, 25 is what you're supposed to get. 55 is what the test actually got.
Oh, okay. So the right one is the 25, and the wrong one is the 5.5.
Yeah, but if you also look at the test and you also look at what answer you're getting, you should be able to kind of triangulate and figure out like which one are you printing out, and then therefore by default the other one must be the correct one.
Mm-hmm. Oh, okay.
Yep.
Thank you.
Yep. Any other questions?